So I think it's helpful to go over some of the short answer questions that you might see on the exam. And I'm only going to consider some of them. And in particular, I'm going to focus on some of the ones that have to do with the relationships between various semantic properties. So let's take a look at some of them. So the first one I want to look at asks the question, if P, Q, R entails Z, then is it the case that the following formula is a tautology? So is it the case that P and Q and R, therefore, or then Z is a tautology? And so what that means is that it is a formula that is always true. Okay, so let's check to see if that's the case. So in order to understand whether or not that's the case, we have to understand what it means for P, Q, and R to entail Z. What that means is that it cannot be the case that P is true, Q is true, R is true, and Z is false. So any other scenario can occur, but the one that cannot occur is this one. So it's possible that P, Q, R are all false and Z is true, or there's some other combination, but one thing that cannot occur is that P, Q, and R are true and Z is false. Now with that in mind, we can ask ourselves whether or not this particular formula is always true. That is, does it express a tautology? If that's the case, we can think about when is this formula false? What's the condition under which this always true does not hold? Well, when we look at this formula, one thing that we see is that it's a conditional, and we can think about, well, what are the conditions under which a conditional is false? Well, the only condition under which a conditional is false is when the antecedent of the conditional, which is the formula to the left of this right arrow, is true, and the consequent of the conditional is false. So this is the only scenario in which this conditional is false. Now let's look at what would be the case if the antecedent of the conditional is true. Well, if we look at this formula, we see that P and Q and R is a big conjunction. And so what has to be the case if this formula is true is that P is true, Q is true, and R is true. And given that we said that this formula is false under one case, it would have to be in the case where P is true, Q is true, R is true, and Z is false. So in order for this conditional to be false, in order for this to occur, in order for this formula to be the case, this assignment of truth values to those formulas has to hold. But let's go back to what we said about the conditional, or the argument here. We said that this set of assignments cannot be the case. We said that this argument P, Q, R entails Z is valid. So we have this valid argument here. So what we can't have is this scenario where what cannot occur, what does not occur, given our assumption, is P is true, Q is true, R is true, and Z is false. And so given that this cannot occur, cannot be the case, and given that the only way in which this formula can be false, which is just the same as saying that it is not a tautology, is if P, Q, R are true and Z is false, then this formula is never false. It's not ever false. And if the formula is not ever false, then it's going to be true. So it's always true. And if it's always true, then the formula is a tautology. So going back to our question, if the argument here is valid, then is this formula a tautology? The answer would be a big old yes. It would be a tautology. Now let's think about the reverse direction. Let's say that P and Q and R, then Z is the formula that we're looking at. and we are going to assume that this formula is a tautology. So it's a formula that is always true, and given that that's the case, one thing that cannot occur, as we saw last time, was that P is true, Q is true, R is true, and Z is false. This is the only assignment of truth values to these letters that would make this particular formula false. And so what we're going to assume now is that this assignment of truth values does not occur. So any other assignment of truth values to these letters is perfectly fine, but what we're saying is that this one cannot be the case. These letters cannot take this set of truth values. Now, given that this formula is a tautology, the question would be, is it the case that P, Q, R semantically entails Z? In other words, is this argument valid? Now, we would say that an argument like this is valid just in the case where all the premises are true and the conclusion cannot be false. In other words, where this scenario does not occur, where it's impossible for the premises to be true and the conclusion false. So provided P isn't true, Q isn't true, R isn't true, and Z isn't false, then we would have a valid argument, because this is the only assignment of truth values to these letters that would make the argument invalid. So the question is, if this formula P and Q and R, then Z is a tautology, is this argument right here valid? That is, can we assign truth values to the letters where it's P is true, Q is true, R is true, and Z is false? Well, if you look, in assuming that this formula is a tautology, we said that P, Q, R, Z cannot be true, or P, Q, and R can't be true, and Z false. Well, that would be the exact truth values we would need in order to make this argument invalid. And so since this set of truth values is not allowed, given our assumption, the answer to this particular question would be yes, the argument is valid. So if this formula is a tautology, then we have a valid argument where the premises are P, Q, R entails Z. Let's look at one more. Let's assume that P, Q, R entails Z. So in making this assumption, what we're assuming is that a set of truth value assignments to the formulas cannot be the case. What we're assuming is that P is true, what we're assuming is that the following truth value assignments cannot occur. P is true, Q is true, R is true, and Z is false. So we are assuming that this scenario does not occur. Now, if we are assuming that this argument is valid, and so we're assuming that these truth values do not occur, the question then is the following set of formulas consistent or inconsistent? And a set of formulas is consistent if it's possible for them to all be true. That is, we can give them a truth value assignment where all of the formulas are true. And it's inconsistent if there is no truth value assignment that would make them all true. So the question is this set of formulas here, P, Q, R, not Z, consistent or inconsistent if we assume that P, Q, R entails Z is the case? So the question becomes, can we assign each one of these formulas a value of true? Well, what would we need? Well, we would need P to be true. We would need Q to be true. We would need R to be true. And then we would also need not Z to be true, which is that Z is false. So if Z is false, that was the only scenario in which not Z would be true. So in order for this set of formulas to be consistent, we would need to assign to the each of the letters that compose the formulas a letter of true, 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 and false. And so again, this is what we would need for this set to be consistent. But remember, this particular truth value assignment, false, true, true, and true, is the exact truth value assignment that is not possible given the assumption that this argument here is valid. And so given the fact that this truth value assignment is not possible or not allowed given our assumption, the set of formulas is not consistent. And so what that means is if it is not consistent, there is only one other option. A set of formulas is either consistent or inconsistent, and so the set is inconsistent. And so if we assume that this argument here is the case, if we assume this entailment, then the set of formulas that we're analyzing here must be inconsistent.